I put this screen, this is from American Geoscience Institute. And they put this out about 7 years ago. And essentially it says if you have a bachelor's or master's degree in geology with additional training, you can go into a lot of different areas of geology. And this is when you registered. This was put in the registration where you could download this and look at it. So the reason I did this is obviously a lot of students may have a passion for other areas outside of the traditional geology careers. I've had a couple friends that actually went on and got masters. After they had masters in geology, they got a master's in library science. And I gave a talk a couple weeks ago at the University of West Georgia, where one of the students said she had a desire to become an environmental lawyer. And a couple of professors that were there spoke up and said, hey, we have a student that graduated a few years that's actually in law school. So you're going to get them connected. So anyways, this is just information only, just to show you that there's a lot of other areas that if you really have a passion, that you can, with a basic geology degree, go into different areas. So we're going to be talking this evening about environmental consulting. And one of the things historically is the environmental consulting firms were initially engineering firms. Back in the 70s and 80s, when most of the environmental laws were written, environmental was added to these large engineering firms. The engineering firms did mostly civil engineering, mechanical engineering projects, big public work type projects. And when the environmental laws came into existence, that's when they started hiring lots of geologists to work in this area. Obviously, they hired both bachelor's and master's. And when I say geologists here, I also mean people that have an environmental science degree. I'm not just keeping it just to geologists. In all of these areas here on this slide are different services that environmental consultants offer. Some of them offer every one of them. Some of the small companies may only do one or two of these. So anyway, I'm going to kind of go through these initially. The property transaction, I had this up first, phase 1 and phase 2, is when you get hired by a consulting firm, this is probably one of the first things you're going to learn how to do. They'll teach you how to do it. And we're going to go a little more detail here in a little bit. I'm talking about phase 1, a little bit about phase 2. When I talk about environmental compliance, there's lots of industries that have lots of permits. They may have air permits, water permits, land disturbance permits. They may have underground storage tanks. They may have drum disposal on their property. So they hire consultants to go out there to make sure all their paperwork, that they're in compliance. They'll also go out there and inspect the facility to make sure that what they say on the paper, they're going by their permit and that they're staying in compliance. So it's a very important job. The landfill compliance, obviously landfills have groundwater contamination issues, and they also have methane production. We'll talk about a little bit about that in a few minutes. Site characterization is obviously if a company knows there's an issue with contamination, they'll install monitoring wells to delineate the plume and to give a good characterization of both soil, groundwater, and maybe even air. UST underground storage tank removal is still a big part of the industry. There are a lot of companies out there that specialize in that, maybe removal old tanks and put in new tanks. And as part of that removal, they have to take soil and groundwater samples. A lot of the small companies may not do the site remediation. Once you've delineated a site, and you typically would do a pilot test to decide how are you going to remediate, or you can recommend long-term monitoring, that you will install a remediation system. And this is very important on how you're going to finally clean up the site. And then water resources, the last one I have here. Obviously, cities, municipals, and industries need additional water in different areas as some of these industries and cities grow. So that's also a service that a lot of consultants add. One thing I do want to add about environmental consultants, I said at the very start when they were really almost all engineering firms. Now there are a lot of geology-owned environmental consulting firms out there, and a lot of them will do all these type of services for their clients. So I like to spend a little bit of time on phase one because I really think that's one of the first things you're going to do. You're going to learn from a consulting firm. Phase one is essentially it's a research of the property, determine if there's contamination on the property or if there is a nearby property that has contamination that could migrate onto your property. It's only a report. You have a client that you're reporting to. It may be a bank, it may be a lawyer, a commercial developer that they use to say, is there problems on the property itself, or is there potential contamination that can migrate onto the property? It involves the assessment of a piece of property using documentation about the history of the property, and also what visual observations you make when you visit the property as part of a phase one. It does not involve any sampling, analytical data, no soil groundwater sampling, and no remediation. Those are considered phase two or either further phases if you're actually going to go as far as remediation. This is a kind of a near-term regulatory history of phase ones. In 2005, the EPA issued standards of what they called all appropriate inquiry for various defense against liability under CERCLA. Under CERCLA, if you have contamination on your property, then you could be responsible for cleaning it up. So as part of the defense, you can say, I did this investigation and determined there was already contamination when I bought the property, or there's potential contamination that can come onto my property from off-site where I should not be responsible. In 2006, prospective purchaser must follow the federal standards under 40 CFR Part 312 when conducting these type of due diligence. Performance of a phase one really incorporates the data in a defense as an innocent landowner defense. And the phase one is really considered a first step in due diligence as to what the site characterization is, and if you decide to go on to a phase two. So what are the main elements of a phase one? Obviously, there's a records review to identify what they can call a recognized environmental condition. And these are government, both federal and state databases that will be reviewed. You'll have historical maps, you'll have aerial photos, you have city directories to see what's the history of the property over time. As part of the phase one, you also have a site reconnaissance where you'll actually look for these recognized environmental conditions, such as staining, drums on site, paint, solvent waste, thinners, petroleum spills, transformers that may have PCB or other problems you may identify on the property. You know, dead grass that may identify that something's been spilt there that may be a contaminant. Also, as part of the phase one, you'll do interviews. You'll look at current and past owners or operators to really learn something about the site history, that you may be going to a closed site and really not know what was there 20 years ago. So it's very important to do these interviews of people that have some knowledge. And at the end, you determine if you have recognized environmental conditions that are present and what your recommendation will be for the property. There are a number of companies that actually supply you the databases that you use to review for a phase, for a phase one. EDR is one of the companies out there. There are a number of them. I wanted just to show kind of some of the things they supply. One of the things they have is Sanborn Maps, and these are really insurance maps that were created between 1867 and 1970. And they were mostly in the larger metropolitan areas across the country. And they're really good assets to see how properties changed and to look around the property itself and see what changes there's been over time. So they'll give you a series of maps, these insurance maps. Another area they'll supply will be some topographic maps. on here, the map on the left side is a topo map from 1894, and the one on the right is 1974. So you can see how the cities are changing over time. Maybe you'll see other information, pipelines, other things on these topo maps to help you identify how it's changed over time. They'll give you a series of aerial photos. The one on the left is from 1969, and the one on the right is from 2012. And if you look over that kind of top right-hand quadrant, you can see how it's changed over time between those years. A lot of the aerial photos that I've seen are from very, very high altitude, not very good quality, but they will supply you whatever is available. These maps are very good quality, so you can pick out your site. This is kind of the meat of the whole report that's reported by the EDR. The top part is all the databases that are in the federal control. Then at the bottom part is state and tribal databases that they get the information from. The second column is the minimum distance. This is a radius around your site that they look for these lists to see, are there any sites within these areas, radiuses. And then on the far right is how many sites they found. So in this case, you have one site that's on the federal circa list. So now you've done your interviews, you've reviewed all the data, you've done interviews and site visit. So now you incorporate all the information. But as a geologist, you need to look at other information. What is the subsurface conditions of the area? Do you have sinkholes? What kind of geology? What type of soil types do you expect to see? Even though you don't drill out there under phase one, but what type of soils do you expect to have? What depth is bedrock, or is there bedrock in the area? What kind of groundwater you have? How deep groundwater is? Which is the direction of groundwater flow? Are you upgrading or downgrading of a potential contamination source? The topography of the area, where is surface water runoff? Could it come onto your property because you're kind of sloping down from a high area? So a lot of this information you can get from the state geological surveys. They have great references for a lot of these areas that will help you. But these are other material that you'll need to include into your phase one. So if you say, yes, we have some recognized environmental conditions, we recommend to do a phase two where you actually go out and drill and collect soil and groundwater samples. So depending on the size of the property, typically it's a one-day site investigation. Usually they use direct push rig and will collect 3 soil and 3 groundwater samples. Wells are only temporary and will usually be abandoned after you're taking your samples. There's no groundwater elevations collected, so you can't produce a potential metric surface map for your client to show which way groundwater is flowing. So here's a picture of a geologist with the geoprobe in the background. You can see this is a residential area. And what they have, the geoprobe does direct push, and they have these plastic sleeves that are pushed in the subsurface, so you get a continuous lithology of the subsurface. You can look at it. You can kind of guess where the water table is. You can also screen for contamination. And obviously describe the lithology that you're going to be drilling through. Here's another geologist collecting groundwater samples for a phase two, where he actually has a Geoprobe unit. And if you look by his feet, there's a couple bottles that he's filling up. So let's turn to landfill compliance. This is another area where landfills, obviously the major problem is the creation of methane in the subsurface of a landfill. There also can be groundwater contamination, but usually the major issue is methane. Typically what happened over the years is, in the bottom pictures, is they collect the methane and flare it off. Now what more and more of them are doing is they're actually using methane gas. The top picture isn't very good because I'm looking through a glass window, but this is in DeKalb County, Georgia, where they actually can collect the gas, run it through a series to get the impurities out. And at the end, they can use the natural gas that they collect and use it for the county buses that run on natural gas or the vehicles on the property. If there's excess gas, there's actually a gas pipeline on the landfill that they can actually sell the gas back to the gas company. The picture on the lower left at that time was an active landfill. Since then, it's been closed. They've actually put solar panels on top of that landfill. And the picture on the lower right is a different landfill where they collect the gas, they clean it up a little bit, and then they actually run the gas through a generator to actually produce electricity. Electricity goes back into the grid. So it can be a valuable resource for the landfill. As a new hire for a consulting firm, probably for the first couple of years, you're going to be out in the field an awful lot. And when I talk to students, they say, great, they'd love to be outdoors and not in an office. So all these tasks here that I'm going to go through are some that consulting firms will teach you how to do. Obviously, you're going to be installing monitoring wells and describing soil samples. Very important to get as much detailed information you can when describing soil samples. You'll collect and properly field screen soil samples. When I talk about field screening, you're actually using an instrument, usually a photo ionization detector or flame ionization detector, to screen for volatiles in soil samples. And you're looking for contamination. So they'll teach you how to use this instrument. You'll develop and purge monitoring wells. You'll learn how to groundwater gauge. This is used for creating potentiometric surface maps of the site. And then you'll learn how to sample the groundwater. UST removal, as I said earlier, is still a big part of the industry. And when you do a tank closure, you do take soil and groundwater samples. There's lots of equipment, and this is just a partial list of equipment that you'll use and learn how to do. The PID, photo ionization detector, flame ionization detector, pH temperature meter, redox, dissolved oxygen, conductivity, LEL or O2. You'll learn how to survey in a lot of these companies. Air sampling has gotten to be a big, and I'll talk about that in a little bit. And even slug tests, and these are used for pilot testing before you decide on how you're going to clean up the site. Obviously, you'll also maybe be dealing with free product removal, the free products that's in the subsurface, or enhanced fluid recovery. So here's a series of pictures I'm going to show you. Here's kind of the typical rig for a hollow stem auger, and this is generally what's used when you're drilling monitoring wells. You continuous drill, and then when you want to take a soil sample, what they have is a split spoon sampler, and this is usually an 18 to 24 inches, maybe a little longer, where you can actually, there's a hammer on the rig where they hammer down to the subsurface. It has a stainless steel tube that you can open up and describe your soil samples and collect soil samples for laboratory. Typically what they do is you can do these continuous, but more so than not, what they do is they take a sample every 5 feet for you to look at and describe. Here's the picture on the left is a geologist, and he's demonstrating this to some students of a PID where he's going to screen the soil samples for contamination. The picture on the right is after he's screened for soils and he's decided what samples he wants to take to actually send into the lab. He's getting ready to collect the sample, and here he is put into the jar that will be sent off to a laboratory for analysis. After the well has been drilled to the total depth, and usually that's below water table, they'll install a monitoring PVC well screen. And the lower part of the screen is slotted where they can, so water can migrate into the well. And then above that, above the water table, a little bit above the water table, they'll put a riser, which is a solid screen, solid piece of PVC without any screen in it, so water can't migrate into it. As you notice in this picture, you can see both drillers are wearing gloves, and so there's no contamination to get on the PVC pipe. Typically, after you install a modular well and you go out to sample it, you purge the well. And this is what I mean by purging. Is the standard is you'll move 3 volumes of water that's in the well before you actually sample. So here, the water is being purged out of the well. And then after you've purged it, then you'll grab a water sample. Here he's filling up a VOA jar. These are very small jars. If you look by the drum there on the ground there, he's got a couple of VOA vials that he's either filled up or he's going to fill up. And these have to be filled up completely without any air. And here's a picture of a UST being removed. And there's still USTs across the country that still need to be removed. So a lot of companies do a lot of work of either removing and later on putting in newer tanks into the ground. This is a picture of kind of different types of remediation systems that I've seen over the years. And typically in the top left-hand drawing is more as what we see today. The reason is if it's in a active commercial area or if there's homes nearby, it's actually all enclosed. It has insulation to keep the noise down, and also because it's enclosed, equipment is out of the weather, and also it's less chance of being vandalized. When it comes to cleaning up the groundwater, there's obviously lots of different methods that can be used. You can use it mechanical. The top 2 pictures are where the top left is where you actually pump the water through the system and separate the contamination from the water, and then you burn the volatiles. The top right is where they're air sparging or using vapor extraction to extract volatiles from the subsurface. There's still a lot of areas where you actually go out and if there's soil contamination, you dig it up and dispose of it. The lower middle picture is where they're actually injecting different types of chemicals to destroy the contamination. In the lower right picture, they're actually using chemicals to actually go into the bottom of this pit to the groundwater and mix these chemicals again in the groundwater to hopefully destroy the contamination. Besides consulting firms, there are a lot of specialty type companies out there that can help consultants. And this is Fugro, which is out of Houston, Texas. And there's a lot of other companies like Fugro that does the same type of work. And what they have is they have a hydraulic push rods inside the vehicle where they run specialty equipment down the hole that will identify the type of lithology going through. Are they in sand, silt, or clay generally? And then there's also sensors, laser sensors that can identify, are they going through areas typically of gasoline or diesel? This next picture is inside the vehicle, where the left picture is showing the hydraulics pushing down the tubes. And then the monitor on the right, it's hard to see, but you can see a little blue, yellow, and red, which will identify, are they looking at gasoline contamination or are they looking at diesel? And this is really important information because you may have some of the contamination above the water table and you may have some at the water table and even below the water table. So this will give you an idea of where the contamination is, where you need to direct your remediation. Other services are vacuum units. I know of two different geologists in the Atlanta area that own vacuum units. And these can be used for, obviously, if there's free product of gasoline or diesel in subsurface, you can have these units come out. It's very small and help remediate the site. Also, if you're doing pilot tests and designing the remediation and seeing what kind of remediation system you can use, a lot of times they'll use a vacuum truck to do this pilot test. So they're a very important piece of equipment that consultants not going to have. Air sampling has really gotten to be important probably the last 10 years, where they're worried about vapors getting inside buildings. So there are, I know of a friend, a geologist that specializes in this, of collecting air samples to determine if there's issues. Another area of help for a consultant is seismic. You can have seismic refraction, where in this case, in the picture on the left, they're looking for how deep is bedrock, and it may not all be a uniform depth, but they want to see where they'll be hitting rock. The picture on the right is ground penetrating radar, where it's very shallow radar, where they're looking for obstructions such as pipelines, underground storage tanks, or other obstructions that are in the subsurface. And then water resources obviously is still going to be big for many years, where both municipal and industry needs additional water resources. So this is another area of help. This is a picture below New York City, and the picture on top left you can see is the Empire State Building, and then to the right of that little building is really the elevators that goes down into the tunnels below New York City. In New York, they get all most of their water comes from upstate New York, goes through a number of aquifers or through a water system. Then when it hits the city, it's in a series of tunnels all throughout the city. The lower left is part of the what they call the train of the system. While it's really the tunnel. The picture on the right is the actual head of the tunnel. The actual blades that they used to grind the rock have been taken off because they were, when I was there, they were getting ready to turn and go in a different direction. So they're disassembling the equipment to turn the whole train around and go in a different direction. Because like these companies were originally engineering firms, that a lot of them still do geotechnical. So I thought I'd throw in a few slides here where a lot of times when they do geotechnical, they actually find contamination and turn it over to the environmental. But this is another area that some companies have where they're here, they're actually collecting samples for the foundation. These pictures were taken at the Greyhound bus station in downtown Atlanta that I managed for the state. Another area that geotechnical is very important, obviously, is looking for landslides in the left picture. And the picture on the right is a geologist going down a caisson to make sure the caisson is into bedrock. Next, I'm going to show you a little video.
That massive rock slide in Polk County has caught the attention of the entire country. Seeing the spectacular act of nature has many wondering just why it all came tumbling down. When seeking answers for tonight's top local story. The very first thing that jumped out was the sound. The popping sound, like a car door being slammed. A clear sign of trouble to TDOT geologist Vanessa Bateman.
We couldn't see the rock moving, but you could hear it. And that's the kind of sound when it makes that. It's starting to let loose up on the slope.
Sure enough, minutes later, a wall of rocks, trees, mud, and other debris tumbled to the ground, blocking Highway 64 in the Ocoee Gorge. But what caused this awesome show of Mother Nature's power?
Rock in the Ocoee is not unlike this rock.
We went to Dr. Jonathan Meese in UTC's geology department for answers. He says the rocks in the Ocoee have weak spots called cleavage planes.
Typically, water gets into those things. They are likely to slide. And so, in looking at that video, it appears that large slabs of rock slid off of smooth surfaces like that. And I would suggest that this is really a recent past slide.
Dr. Meese discounts the mild earthquakes we see in this area as a trigger for this slide.
Certainly, anytime the ground is agitated, you couldn't ignore it. I don't see it as a real influence here.
Instead, he points to recent wet weather as the culprit.
I'd associate this slide probably as much with the rain as anything else. And that's quite common for these sorts of rock slides to occur at times of rain.
An act of nature that put on quite a show.
All of a sudden you hear the rumble and the whole thing.
And Dr. Meese points out earthquakes are fairly common around here. We're in the East Tennessee seismic zone. That's one of the most energetic areas in eastern North America. They tend to be small, though, with no damage.
So I hope you enjoyed that. So anyway, so geotechnical engineering, obviously they use their geologic knowledge to solve engineering problems. And a lot of these projects are big public works that can include a reservoir, the location and design of a reservoir, power plants, transmission lines, tunnels, highways, wind turbines, pipelines, water treatment plants, airports, and harbors. But they also do geologic hazards such as slope stability, geotechnical problems, erosion, dewatering, and flooding. Because I work for the Georgia Environmental Protection, I wanted to at least expose you to potential jobs with the state. In Georgia, it's called the Georgia Environmental Protection. In Oklahoma, it's called the Oklahoma Department of Environmental Quality. And also there is the Oklahoma Corporation Commission that regulates underground storage tanks in Oklahoma. So why I think it's important that you at least consider working for a state, or I'll talk a little bit about federal jobs also. But essentially, as I said earlier, a lot of the environmental laws came into existence in the 1970s and 80s. So the first generation of geologists that were hired back in there are now all retiring. In fact, most of them are retired now. So there's going to be a need for replacing these geologists. And there's also still a large number of sites in all the different programs that need to be addressed. Also, environmental laws change over time. We've had new contaminants that we didn't even know about 5 years ago that are now being addressed. So that's also going to be a real issue. Also, a lot of the environmental protections also are in charge of the natural resources, which also has geologists. And then I have here the last one, turnover in environmental specialists. The environmental specialist in Georgia is really an entry-level job for geologists or environmental scientists. Now, I'll talk a little bit about that in a few minutes. So what programs are there within the state program that hire geologists? Well, obviously there's solid waste management to having to do with the landfills to make sure they stay in compliance. Surface mining usually is a very small group of geologists. Underground storage tanks, at least in Georgia, is one of the larger groups. There are hazardous sites that are both state and federal that the state takes care of. Brownfields is a unique group. The developer comes to it and typically wants to redevelop a blighted site and will come to the brownfields area. And this group will work with the developer to expedite the cleanup of the site. And there's also tax credits that the developer gets. So this is very important. It's a very big plus program that people like to get blighted properties off and get them to be some useful property again. Wellhead protection is for drinking water wells to make sure that there's certain radiuses around these wells, that certain industries cannot be built within these radiuses. So the protects the well from being contaminated. Also, you have injection permits, and the picture I showed you earlier with the injection of chemicals in subsurface actually have to get a permit before they can do that from this group. And also there's water withdrawal permits, both municipal and industrial, that have geologists. So here's a picture of a new landfill cell. Before they actually build the cell, they'll do a susceptibility study for the area to make sure they can actually build the cell. And in Georgia, it's actually a geologist with the state that reviews this report and has to approve the report before they actually build this new cell. Typically in the state government, in the environmental protection, most of the time you're in the office. Now, obviously right now with the virus, everybody's working from home, but they don't go out in the field much right now, but because of the workload. And but they do encourage you to go out in the field to see all the different aspects of the drilling, remediation, investigations that are done throughout the project of the site that you may be in charge of. So there's 3 different pictures showing different types of geoprobes This is the site I showed you earlier, Lisa, that we're taking geotechnical samples. This is a Greyhound site in the downtown Atlanta, that had a major diesel release over a long period of time. It wasn't from the tanks, but it was from the piping. It migrated below the facility and also migrated across the street below a parking garage. So while we were actually remediating the soils and the groundwater contamination, they were actually starting to build the building that's on the right. So that's one of the things that was very gratifying to work for the EPD, where I could see properties that were blighted not being used anymore to be now. Here we got a nice high rise in downtown Atlanta. Here's the Ford plant that was torn down. It's near and it was torn down. And this was the largest remediation system we've ever had so far in the Georgia Underground Storage Tank Program. In the picture to the right is the Porsche USA headquarters there. And the lower picture of the building on the left is the Porsche headquarters. And the building on the right is a new hotel that was built in the last couple of years. I would like to address UST inspectors. This is in Georgia, at least all programs have inspectors that go out into the field to inspect whatever program they're under. And typically we consider these entry-level jobs. And they'll teach you how, whatever program, these are all obviously U.S. underground storage tank inspectors, will teach you what to look for, teach you the paperwork, what the person that has the tank, what kind of paperwork he should supply you, he or she should supply you. And this is a really good entry-level position. A lot of the people, after a few years, they may go into another type of inspection program, or some of them actually become geologists. A lot of the geologists in the underground storage tank program start out as inspectors. The other thing is, if you decide to leave the state and work for private consulting firms, you are considered to be very knowledgeable of what you do. And you're a big asset to a company because of your knowledge of whatever program you're in. And this is a picture of some of our geologists. The one on the left in the middle is one of our geologists. This is a sonic rig that drilled these samples. And this is actually at the Ford plant. And they're just looking at describing the soil samples. The one on the right is also at the Ford plant, where the geologist standing to the right works for the EPD. And we're not out there to harass or anything like that. We're doing a pilot test, injecting chemicals at different subsurface to see what the migration and how it cleans up the subsurface of the groundwater. So obviously we like to get out there just to learn different things, especially when they have new technologies. We really like to get out there so we can learn these technologies ourselves. Besides the programs I went over, there are other smaller programs within the environmental organization of the state. A lot of times coastal management that will deal with permitting coastal issues, asbestos, lead-based paint, radon, radiation, pesticides, scrap tire. Some states regulate heating oil tanks, and a lot of states regulate above ground storage tanks. So these are all additional programs that will have geologists, maybe not in large numbers compared to the other programs that I showed you. Some state programs actually have natural resources under their control, such as oil and gas permitting, that would obviously have geologists. You have orphan wells, and these are wells that are oil or gas wells that maybe the company went bankrupt and they haven't been abandoned properly. They're not producing wells and they have to be abandoned. All these programs of natural resources have inspectors that go out and inspect the facility. You have mine permits, and then you have to do the reclamation of mines. You have coal bed methane, and all these coal resources that have to be permitted and regulated. Besides state, there are also federal agencies. Obviously, you have state research agencies. These are the state geologic surveys. Now, generally speaking, most state surveys would like to have either a master's or PhD, not so much bachelor's. Then you have federal research agencies, including the U.S. Geological Survey, NOAA, and NASA. And then you have state and federal DOT. You have federal FEMA, Federal Emergency Management Agency. And I actually have a friend that left consulting and works for FEMA now. And then you have the US EPA, and I've had quite a few geologists that work for the state of Georgia that have gone on to the EPA. Then the Department of Interior has the Bureau of Land Management, Office of Surface Mining, Bureau of Reclamation, National Park Services. And then also the military branches hire civilians, you're not in the military, you're civilian working for the government at the military facility, managing their environmental releases that they have, or investigations, and in charge of all their permits that they have. Technology has really grown in the last number of years. And I want to go over just to show a few things here. 3D groundwater modeling for contamination has gotten to be really big, where you collect huge amounts of data to actually model the contamination, and also 3D groundwater aquifers. There's large aquifers in the US that go over multiple states, and they want to see how the aquifer is behaving, how it's being depleted in some areas. So it's gotten to be huge amounts of data. Laboratory detections have been looking at new compounds that we didn't even know about. We really have lower detection limits. If you look at old data in the 60s and 70s, early 70s, a lot of that data for groundwater is in parts per million. When I worked, they were looking at, they still do look at parts per billion, but there are some contaminants now we're looking at parts per trillion. So the detection limits have gotten lower and lower. Data management has gotten to be a big issue, is how these different systems are collecting huge amounts of data, and it has to be managed. GIS is one of the things that more companies are using. They can handle large amounts of data where you can put it in data sets. About a month ago, a friend of mine who works for a consulting firm did a webinar having to do with their company and what they do with drones. And they use them for construction projects, modeling. They can run LiDAR on the drone where you can remove the trees and look at the landscape. You can do elevation surveys and look at agronomy to see where crops are having problems. It may need to be nutrients or water. You have mineral surveys, you have slope stability, and even solar farms. They can go over a solar farm and identify solar panels that are not working properly. I would like to talk just for a minute having to do the licensing. Currently, there are 32 states in the US that issue professional geologist license. Oklahoma is not one of those states that has licensing. But I want to tell you why I think it's important. ASBOG is the organization that actually puts on the test. It's a two-part test. You have the fundamentals of geology exam that typically you take right after graduation with a BS. And then you have to work 5 years under the direction of a licensed geologist or engineer. Typically it's 5 years. Other states may have different times. And then you have to take the second part of the practice of geology exam. Once you pass both parts, you can become a licensed professional geologist. If you work for a consulting firm, you're considered to be offering geologic services to the public. And that's why the state's regulated. It's also very important. When I got my PG license, the company I was working for gave me $1,000 bonus, so that was nice. Companies need licensed PGs or PEs, and the reason is there's certain documents that have to be signed and sealed by a PG. And because of this, when I worked for the state of Georgia, and a report came in that had to be signed. When I wrote a letter to the owner, what I would do is send a letter to him, and I'd copy whoever the PE or PG is, so they know I'm holding them responsible for whatever I'm asking for in my letter. So anyway, I kind of want to finish up this presentation on what are companies looking for, and kind of give you insights of when you get to the point of when you're going to start interviewing for companies and really start to look for companies. And these are some of the things they look for. Ask, will you fit in with the company? You know, they know there are people that work for them. Do they think you will fit in with the employees? Do you have a good attitude? Typically what we say, will you play and work well with others? That's also very important. Are you a good learner? Can you take on initiatives on your own? Can you get things done on time? Are you going to be an employee where they don't have to hold your hand, that you can take the initiative, get things done? And if you get into trouble, before you get in trouble, you'll ask for help. But these are all good things that they're looking for. One of the major things they want to know is, can you write? This is one of the biggest complaints consultants have. When you do your work, you're making a report that goes to a client, so it has to be well written. So this is extremely important. This is one of the biggest things that consultants complain about, is the writing of a lot of the students coming out of college. Another thing they want to know, have you done any oral or poster session presentations? And why this is important is somewhere in your career, you're going to have to make presentations in front of clients, talking real technical information, but you have to put it into layman's terms where they can understand what you're talking about. So oral communication is also very important. When I reviewed resumes and looking to hire people, I also look at, do they have any leadership skills? And that shows that these are the go-getters. Are you an officer of an AIPG student chapter, or if you have a geology club, or even outside organizations that you're involved with, that you've taken some kind of leadership position, really shows something that people are looking for. We also look for, if you've done a senior thesis or graduate thesis. This shows that you take on a project, complete it, and hopefully write it up where it's part of the Can You Write, that you have some good writing skills. If you have an internship with an environmental firm, something that's in the environmental field, this gives you a big plus. So those students that have internships can be really brought up higher in the list of people that you're looking at. Experience working in lab, because you're in the environmental field, you're working on lots of different equipment. So that's just not necessarily the same lab equipment you're going to be using, but that you know how, you have some idea of how to use different instruments. And do you have just really any kind of work experience? Not necessarily having to do with environmental, but just general work experience. You can get up, get to work on time, do 8 hours of work or whatever, and go home and leave on time. These are all important. Now, one thing I want you to look at this list. Nowhere did I ask what your grades were. Grades are important, but we can all consider that you've all got geology or geoscience degrees. But grades aren't looked at as much as all these other issues that consultants are looking at. So anyway, so that's the presentation. I have my email address if you'd like to email me directly. I would like to say one last thing is, for the students, I really recommend that if you're an AIPG student member, to use it to your advantage, especially when you get close to graduating. It's a lot easier to reach out to, making a cold call or sending an email to somebody that say, hey, I see that you're an AIPG member, I'm a student member, and I want to learn something about your area of work. And they're more likely to talk to you because you have something already connected with the individual. So it's very important to reach out to AIPG members. I've had students graduate from Georgia and they moved to California, and they said, do you know anybody in California? And my reply was, what part of the state, north or south? So anyway, so there's lots of geologists across the country, that, especially the geologists with AIPG that have been around for a long time, have lots of contacts all the way across the country. So it's very important to use that resource when you start looking for companies. So that's my presentation. Michael, do you want to take over?
Well, what we'd like to do is, I think it'd be easiest if you have a question for Ron. And by the way, Ron, thanks. That was fabulous. We really appreciate it. You taking your time to present to us. And if you have a question, go ahead and type something out in the chat box, and we'll read it out and have somebody fill the answer to that question. Yep.
Like they say, no question is a dumb question. So it's a good opportunity to ask some professionals a different questions. So take advantage of it. Especially, I appreciate all the students that are on here. I know you've been in class all day, or you've been on remote from home, and then to listen through this through the evening, I really do appreciate it.
We've had a couple of people that would just like to ask verbally. So we have, let's see. Cameron Graham, would you like to ask a question?
Hey, can you guys hear me?
Yeah.
You can.
Hi, so I'm currently a master's student at the University of Tulsa. I'm doing my master's in geophysics. So I have an undergraduate degree in geological engineering. So everything that you've showed, Mr. Wallace, has really kind of hit home and is kind of in the ballpark. And there was one question specifically. So the ASBOG has been on my radar for a very, very long time. And one thing that I found really difficult, especially in my undergrad, probably more now, is that there's really no dedicated study material for that exam, as far as I'm concerned. I studied for it at one point in my undergrad, and it was all handouts from teachers and professors that had actually been on the I went to Ole Miss, that had been on the Mississippi board for it. So how would you recommend studying for that, especially if, you know, I'm kind of deep into a master's degree in geophysics?
Sure, sure. Well, there are a couple of things. You can go onto the ASBOG website, and they'll actually tell you what percent of different areas of geology that the test includes. So you can see so much paleo, so much igneous metamorphic, so much sedimentology, so much hydro. So that could be a first step. And they actually do have, I think, a few questions on their website that they ask. The other thing is, what I did was just take my basic geology books and, you know, introductory geology and all, you know, the different areas of geology, and just kind of went through and reviewed a lot of that material. There are companies out there that sell flashcards, but I've talked to some people that actually are on the ASBOG board, and they really don't recommend it. That's the way to do it. But I would go back and really just review your basic geology that you have and see what areas that you think you may be weak in. One of the things, if you are an AIPG member, you can go into the TPG magazine, and each issue has a section of questions that are kind of typical questions that maybe ASBOG would ask. So you can actually, you know, and all their, they're all online, so you can go back and look at different issues of the TPG and review those questions to take the ASBOG.
Okay, that's.
But I would do it. But I would recommend it. I know it's problem because you got to go to another state to actually take the test because they don't offer it in Oklahoma. Right. But I really recommend as soon as you can take it because I took mine probably after I left Exxon. When I got in environmental, I realized I needed my PG license. So it was a good probably 13, 14, 15 years after graduating my master's that I took the test. And so I really had to study hard.
Yeah, yeah. Well, thank you so much for the information. It's
Sure.
something I want to address very
soon. Absolutely. That's very important that you get
thank
that test done.
We have a question from Victor.
Ron, thank you so much for a great presentation. Can you hear me?
Yes.
Great presentation, great overview. Could you go back to maybe like one of the very first slides, second or third, when you have an overview of different areas where the geologists could apply their skills?
Ooh, I wonder how I can get out of this thing. Hold on, let me see. Hold on. Let me pull it up again. Okay, what slide were you talking about?
It was like second or third slide, maybe. Let's just start flipping and I will tell you which one I'm. Not this one, go further. Yeah, yeah, yes, that's a good one.
Okay.
So you are providing like a list of potential areas where the environmental professionals or geologists could apply their field in the environmental area. But
Right.
what about more like ecological type areas, like for instance, different types of wildlife studies, aquatic biology studies, biodiversity studies, and going into a broader area, some kind of environmental baseline studies, environmental impact assessments. Somehow you didn't list those.
Right, right. Yeah, those are more biology, more so than geology, I think. And there are companies out there that just specialize in these areas.
But generally it's kind of physical, chemical, and biological. So
Right.
for geologists, of course, it's much easier to apply his or her skills in the area of physical or chemical characterization of the environment. But nevertheless, a number of people in my circles, including myself, ended up managing a large-scale environmental impact assessments, where there was, besides all of the stuff that you have described, there was a number of various biological elements and even some social elements. I personally managed some archaeological surveys and social baseline studies.
Yeah.
Now, I'm just wondering, is there a specific reason why you did not include it, or you just wanted to focus on those?
I don't have, well, partly focused because I talked almost for an hour just on this. And I don't have a real strong background in those areas.
Okay.
You know, I'm more of the pure geologist and not these essentially biological issues. But these are, what you're saying is still very important. And there are companies out there that obviously do archaeological studies and look at the bio in the groundwater for, you know, different issues of cleaning it up. So I know you're and other biological contamination that's out there. So it is important, but I just don't have a background in those areas.
Got it. Okay, thanks so much.
Okay,
Thank you, Victor.
Good one.
We have a question from Taylor.
Yes, hello.
Yep.
Hello.
Hi, I'm Taylor. I'm currently on I'm a junior in undergrad at Penn State University. And I'm majoring in geoscience, BS, but I'm also majoring in material science and engineering. That's one major, long name. So a double major. And I currently don't have plans on going to grad school, but my question to you guys is, have you seen, maybe not have you seen, but do you guys think it's plausible to kind of, you know, leverage a double major in the field of geology without having a master's, but kind of elevating myself in terms of standing above someone who's just, you know, right out of college with only BS in geology, you know, having that engineering background? You think it would be possible to kind of catapult myself into more technical roles out of the gate, or does it still really require that master's in geoscience or geology?
No, I don't think so. Because there's a lot of bachelors out there that working for environmental consulting firms. So having your double major, I think, is a big plus. And I always tell students, you know, when I graduated my bachelor's degree, I worked 3 years before I went for my master's because I knew I really needed to go for a master's. But if you're not ready for a master's or have no desire for a master's, with a double major, I think you could do very well, especially with the engineering background. That there's going to be companies out there that's going to be very envious of getting that kind of a person with both engineering and geology background.
Okay, yeah, thank you. I was kind of looking into, I know, you know, in construction, aggregate, things like that, you know, that's a big intersection between like material engineering and maybe applications of geology.
Right.
Okay, cool, thank you.
Yeah, good luck.
Thanks.
We have a question from Annie. Annie, are you there?
Hi, sorry. I was wondering if there were any what would you call it? Is there anything that you would call a red flag on a resume? Is there anything that you're not looking for? You made a lot of great points about things that you were looking for, and I am planning on checking a lot of those boxes, but is there anything that you don't like to see on a resume when you're trying to hire an environmental geologist?
Sure. I had a friend that works for a consulting firm. He said the one thing that really made him mad more than anything else is if they're looking at a resume and the student at the bottom says, references on request. He says, why don't you just give me the references? He said, I don't have no desire to have to call the student asking for the references if I like them. If they can't give it to me the first time, then the heck with them. I'm not gonna talk to them. So he was very adamant about that. So anytime anybody asks me about resumes, that's the first thing I tell them. The other thing I would say is if you've worked for, let's say you've worked for half dozen companies, and none of them have to do, they could be fast food, you could be a waitress, you could do anything, but it's not really environmental or it's not geology. I would not go in there on your resume and give all the details of who you work for and the time. I'd put them all together and say, from this time to this time, I worked in, food service or, whatever area you're working, work for the phone company or whatever, and do it that way, just so they don't care. They want to see that you've worked, but they don't care about all the details, especially if it's in areas outside of really environmental that we're talking about today.
Great tips. Thank you so much.
You bet. Good luck, Amy.
We have a question from Heidi. Heidi, are you there?
Yeah, sorry, I was muted.
Perfect.
I'm a master's student in geology over at the University of Texas at San Antonio, and for my thesis, I'm using geology and geophysics because I really like geophysics. So I was wondering if you could expand a bit on how geophysics is used for environmental work, and if I was interested in doing that aspect of an environmental job, how I could get into that.
Okay, well, I had the one slide showing using ground penetrating radar, or I can't remember, refraction or whatnot. So there are companies out there that do surveys for environmental. So I recommend that you kind of search for those kind of companies, because typically environmental companies may not themselves have that. There'll be an outside company that works with the consultants for seismic work.
Thank you. That's very helpful. I wasn't sure if it was like an in-house thing or if they worked with other companies. So
yes, mostly other companies, I think. Yeah.
Okay. Thank you.
Thanks, Heidi. We have a question from Eleanor.
Hi, I just wanted to get your perspective on if there's any work that is preferred for a geologist that an engineer can't do.
Well, obviously, any of the monitoring wells installation, any groundwater or soil descriptions, all those areas, typically engineers do not have the background. So anything in the subsurface, if you're really looking at the geology where it's important, geologists can do that, and really engineers really don't have the background, most of them, to really know what they're talking about. Not being ugly about it, but typically geologists have a foot above them because they understand what's going on more so than engineers.
Well, I appreciate hearing that. I keep getting tips that an engineering master's is going to do more for me than a geology master's. Not
necessarily. It depends where what you're going into, I guess, maybe. The pay may be a little higher for engineers. Historically, engineers get paid higher than geologists, but you can still have a wonderful career in geology.
Great, thank you.
Okay, thank you.
And we have a final question from Christina.
Hello, thank you. Great presentation, Ron. I just recently graduated with my master's in geology overseas, and I currently am working in Pennsylvania in the fracking industry with a consulting firm. And am working to get my drone license, and I was just wondering and curious, throughout your experience and years in the industry, where do you see the applications of drones used in spill response or environmental cleanup, methane detection? Do you see it really being prosperous in the future?
Oh, I think so. The friend of mine, they made a presentation last couple of weeks talking about drones. They've got a half dozen different types of drones. They have the helicopter types and the ones that, that can fly long distances and whatnot. And they limit it to only a few people that can actually work the drones. He said, and in fact, he said some of the drones are backlogged even by over a year. So drones are getting to be very popular. Excuse me, I think as the technology grows and the sensors grow, what you can use a drone for is only going to expand. I think that you're going to see a lot more people where, especially it's in remote areas that you can't get to easy. It's a lot easier and cheaper to use a drone to get to, especially larger pieces of property that you're investigating. So no, I think drones are going to be a big, big area of growth.
Okay, thank you.
Okay, good luck.
Thanks.
We have a question from Max.
So, okay, here I am. Can you hear me?
Yep.
Okay, so I was wondering, where would one start looking for larger scale, like infrastructure scale applications of environmental geology? So I'm out of Detroit at Wayne State University working on my master's, and it's looking at things like street dust, fugitive emissions, and so forth, that are kind of not something like any kind of specific spill, so to say, but something that's a bit more, takes a bit more of a big approach to it to address. So I'm wondering, like,
So
where,
what's the exact question?
so yeah, so I'm wondering where would so if I'm interested in, say, tackling that, or what kind of, or bringing these solutions to fruition, what kind of organization would you suggest I start looking at? Would it be state, company, so forth? Yeah.
Well, what I do is get on the internet and Google it and see what you can find. Any company that does a lot of work, they love to brag about this. So you can go in there and look under a company's website and see if you can find reports that they'll put online to match what you're interested in. And everybody likes to brag about their successes. So I would hit the internet and really just Google different things that you're looking for and see if you can find some companies. And then what I do is actually contact them and say, hey, I saw you did this study, and try to talk to somebody that was involved in it and find out, essentially you want to find out what the company does. And it seems like it's something you're interested in, and there may be an opportunity to actually talk to them eventually about being hired. But a lot of those intricate things like that, I would just get online and see what you can find. Because it may be, obviously it sounds like more, one area I didn't even cover is working for industry. Like I worked for Exxon in their environmental, and we had geologists that worked for them, but I didn't cover that area. But there are, because really today, this evening, I'm really concentrating on entry-level jobs. And these are not typically entry-level jobs. They're trying to hire people that have some experience. But this is an area that would be worthwhile for you to research and see what you can find.
All right, thank you very much.
Does that help you? Good luck, Max.
All right, thank you.
Any other questions? Shoot them out there. Got a couple minutes. Kathy indicates we'll send a link to the presentation in a few days for everybody.
I have a question, another question, if that's okay. So, as I come into the field, I'll obviously be, an early career geologist, and I was curious, do you guys see how's the work-life balance of an early career geologist? Is it on the whole, unfortunately, longer hours than you would like, or like more than a 40-hour work week, or does it really just depend on the employer and, having a good, being on the same page with your employer like any other job? How does that trend generally turn out with entry-level geology jobs that you guys?
That's a good question. I'm glad you asked it. And those are questions that when you get in the interview process, you should be asking.
Yeah, I'll definitely bring that up.
But typically, they expect you to be out in the field. Another issue I would ask when you interview is find out where their project, or go online and find out where their projects are. When I worked for consultants, I did some work up in Canada. I didn't do any other overseas type of stuff, but I did do some having to do traveling around the country. So it's not unusual, especially if you work for maybe a small firm that maybe they only do most of their work within 1 or 2 states, where maybe you'll drive and be out in the field for a couple of days. But they're going to expect you to be out in the field quite a bit. So there's going to be a lot of traveling initially. And it depends on, obviously what the workload of the company is.
Right.
But I would expect that you're going to be traveling quite a bit in the first couple of years.
Gotcha. Yeah, I don't really mind traveling so much as keeping on the 40-hour work week. I believe my personal health is still...
Max, there will be no 40-hour weeks.
I will agree with that. It is
you
definitely.
have that approach. You right now.
No, I disagree. I think I'd be able to find a company that suits my work-life balance needs. I just need to go looking hard enough.
You'll have to look hard, yeah. Good luck.
But thanks. It sounds like an uphill battle, but I'll keep fighting for it.
We have a question from PJ.
Yeah. Hey, Ron. I am a master's student at Columbus State University, so I know you're familiar. You've been down there a couple of times.
Oh, absolutely.
But I was curious if the EPD has any satellite offices in the North Georgia area. I've been trying to get out of Columbus for a while.
Oh, we have one. They have offices in Macon. There's one in Brunswick. There's one in Cartersville, the northwest part of the state.
Okay, Cartersville is more I want to be up in the mountains, basically.
Yeah, Cartersville would be your closest one, yeah.
Okay. All right, I appreciate it. Thank you.
Sure, good luck.
Thanks.
Anybody else?
Oh, we've got almost an hour and a half, so that's good.
That's right. Well, Ron, again, thank you on behalf of the Oklahoma section for putting this on. We really appreciate it, and we appreciate all the great questions and the presentation. So
thanks a lot. And again, if anybody wants to send an email to me directly, it's rw30075@yahoo.com.
very good.
Okay.
Thank you
Thanks
very
a
much,
lot,
everybody.
Good luck for everybody.
Okay.